Hi sir, my name is Siamala Chandrasakaran. My metric number is 2720 and 47. So today I would like to explain my individual assignment on title Cybersecurity Related Cryptography Method. So as you know that the internet is the fastest growing infrastructure in today's world and it provides opportunity for individuals with nefarious intent. So because of this, we are enabled to protect our personal information and as a result, cybercrime is on the rise. So for this solution, I found that cryptography is the best solution for this to protect our sensitive and confidential data. So cryptography is a sort of secret writing that has been used in Roman era to keep information hidden and or safeguard the message. It also the basic communication that turns into an unreadable form called ciphertext during encryption, and ciphertext is turned into the original text during decryption called plaintext. So there are two types of actors normally that happen in cryptography. First one is passive actors and second one is like active actors. So there are two types of classical encryption. First one is symmetric, second is asymmetric. Symmetric is a type of cryptography system that uses public key to convert plain text into ciphertext. Both the sender and the receiver use the same secret key. So it's a vulnerable to criminal attack and can be hacked because it's easily decoded. But however, if we implement it safely, the chance of decoding is lower. There are three types of symmetric test, triple test, and AES. So for asymmetric is the technology is encrypt and decrypt data using multiple digital key. Two keys are used. One is public key and the other is private key. So public key is accessible to anybody, whereas the private key is only accessible to authenticated user. It thought be safe and secure. So three types of SM3, which is RAS, EIGML, and ECC. So symmetric cryptography. First one is TESS. TESS is a symmetric key block saber developed by an APM team in the early 1970s. So the algorithm turns plain text into saber text using 48 bits after splitting it into 64 bits blocks. So this algorithm is widely utilized in variety of applications including military, commercial, and communication system security. So next is triple text. It is because users did not wish to replace tests because its speed of asymmetric key search against tests began to irritate the test users. But the testing approach was to hacker the way test is used rather than eliminate it entirely. As a result, triple test was introduced by the researchers. So next is AES. AES is used by the United States government to safeguard the sensitive information is used to encrypt sensitive data in software and hardware all the world. Each cyber encrypts and decrypts data in 128 bits block utilizing cryptographic keys of 128, 192, and 256 bits. So next is eccentric cryptography. The RAC algorithm was created by Ron Rivers, Adi Shamir, and Leonard Adler as a public key signature technique. The algorithm employs logarithmic function to maintain the working complex enough to withstand brute force. In addition, it also managing digital signature verification. It encrypts and decrypts general information to securely share data. So next is EL-Gamer. The EL-Gamer encryption is a public key encryption technique based on the Diffie-Hellman in 1978. It encrypts the message and communicates between two parties using asymmetric key encryption. Use the public key to encrypt the message and the private key to decrypt the server end. It's a efficient way to approach the cryptography. So next is ECC. It was introduced by Neil Goblet and Victor S. Miller. It's a key-based data encryption technique that focuses on pairs of public and private key. So next, there are four basic principles of cryptography, which is encryption. Uh, that a message or information must be encrypted to become unreadable in order to protect privacy. Authentication, identifying the source of information is one of the most essential aspects of cryptography. Integrity, it prevents the integrity of data by supplying codes and digital keys to verify that what we receive is safe. Non-repudiation, the principle ensures that the information sender cannot deny she or he never sent information. So there are three types of cryptography. First one is secret key. The original message is known as plain text, is encrypted with the key, sender, and the receiver to convert the encrypted message to plain text. Only those authorized for encryption and decryption could access the key. So second is public key. This technique uses two keys to allow secure communication between receiver and sender. It known as a public key and private key. Once the recipient gets encrypted information, it uses its secret key to decrypt the information into a readable format. So the last one is hash function. This method does not require the use of the key. Instead, it uses the fixed length hash value calculated from the plain text message. It used to check the message integrity to ensure that it has been not hacked, compromised, or infected by a virus. So this table is a comparison of various encryption algorithm. So we can see from this table. And the conclusion, cybersecurity refers to the method that helps to protect against data breaches and security concerns. So, as if modern cryptography is required to offer security and digital keys to guarantee that data over the internet is secure and safe. In order to preserve our information and ensure it reaches its destination safely, we need cryptography to increase the security of confidential information. But in today's computerized world, we run a greater danger of having intellectual property stolen and of becoming the targets of dishonest fraud and impersonation. So we are not entirely safe, even though we utilize cryptography to transform our information into an unreadable format, because criminals are growing intrinsically sophisticated and they become more aggressive as technology advances continue. But I believe that cryptography is one of the safest methods that we can use to prevent our information from the theft. So that's all from me, sir. Thank you.